So in this session we will continue our legacy of organic name reaction series. Okay, and I have already completed approx 25 name reactions on my YouTube channel. You can go and check, okay, in the playlist, right? So now today we will discuss a next name reaction that is called cope elimination. Okay, so basically what we are doing in this, uh, so we have and now you are seeing on the screen, this is our general scheme of the reaction. This is a general overview of this reaction, of this cope elimination. Okay, so I will tell you all the detailed mechanism, okay, after this few minutes introduction. Okay, so let's just overview this reaction, right? So we have taken here in this substrate, that is a 3-degree amine, and we have done this reaction of this 3-degree amine by oxidizing agent, that is H2O2, and here we have taken RCO3H. Okay, so you can take here either H2O2 or you can take here either MCPBA, right? Okay, oxidizing agent, right? Either you can take a H2O2, either you can take a MCPBA. It's your choice. Okay, so now what happened? So this is a 3-degree amine. We have done this reaction of this amine by this oxidizing agent, and now you are getting a 3-degree amine oxide. Okay, yes, it's oxidation reaction basically, this step. Okay, so now you are getting a 3-degree amine oxide, and now after we have given some heat in this reaction, and now you will get a in the product, that is alkene. Okay, by the help of a elimination. Okay, this is a transition state here. This is a transition state. Okay, so this is our transition state, and after this transition state you will get a alkene as a major product, and plus you will get a minor product also, that is N dialkyl hydroxylamine. Okay, sorry. So this is our general overview of this reaction. Let me tell you one more thing is, here this carbon is a alpha carbon, and this is our beta position, right? This is our alpha position and this is our beta position. So now you are seeing in the transition state, this is our alpha position and this is our beta position. So this O minus is taking a proton from this beta carbon proton, right? So this hydrogen is attached to this beta position. So we are just showing that, okay, I am just trying to tell you that. So this O minus is taking a proton from this beta position carbon, right? And then you will get a alkene by elimination reaction. So that's why this reaction name is a cope elimination, right? Okay, so this is all about the general introduction about this reaction, but we will discuss in very much detail all the steps, mechanism, because we know that organic chemistry is all about the reaction mechanism. Okay, so you must have to know the mechanism. If you don't know the mechanism, then you will be in trouble. Okay, listen very carefully. If you don't understand the mechanism, then you will, of course, you will be in trouble. Okay, so you have to very carefully attention here to understand the mechanism, what I am doing here. Okay, what happening in the reaction, I will tell you in the very much detail all the steps of the reaction. So now let's start. Okay, so one more thing before I start, I want to tell you some general feature of this reaction, the important feature of this reaction. Okay, so basically this is a cope elimination, is a basically Syn elimination. Okay, Syn elimination occur, right? Let me erase this. Syn elimination occur in this reaction, in this cope elimination, and you will get a Hoffman alkene. Okay, you will get a product. This is our alkene, so you will get a product, generally a Hoffman alkene, right? Attention on my word, okay? I am saying that generally you will get a Hoffman alkene, okay? But there is a case when you get a Sedgwick alkene, when you get a more substituted alkene, right? I hope you all know this, what is a Hoffman alkene. So Hoffman alkene is basically a less substituted alkene, right? Less substituted alkene, that is called Hoffman alkene. Okay, if you get a more substituted alkene, then we call that Sedgwick alkene, right? So there are two general features. There are two very important features of this reaction, of this cope elimination. First is in this reaction will Syn elimination takes place, and now the second feature is in this reaction generally you will get a Hoffman alkene as a product. It means less substituted alkene, you will get a product. Okay, there is a case also in which you get a more substituted alkene product. Okay, I will tell you the case. Okay, so this is all about the overview of this reaction, right? Now let's start the mechanism. Okay, let me erase all this stuff. Okay, fine. So we are taking here a substrate, that is a 3-degree amine here. This is a R1, okay, and here and this is a R2, and this is our R3. This is a nitrogen here lone pair, right? And we have taken oxidizing agent. I am taking here H2O2. Okay, no worry. You can also take a MCPB also. You will get the same product. Okay. So now I am taking here H2O2. H2O2, right? And you all know that what is H2O2? Basically, H2O2 structure is like this. H2O2. Okay. So this is a lone pair here. This is a lone pair here. Now what happened? This nitrogen lone pair, will attack on this oxygen. Okay, and this bond will be gonna break, right? Okay, so you will get something like this. And I will tell you also why this nitrogen lone pair is reacting on this oxygen. Okay, I will tell you the reason. Okay, so here is the R3 here, and you will get here oxygen, right? Okay, fine, and plus you got a OH minus in the hydroxide anion. Okay, now yes, of course this is a R3. Okay, this is our R3, and this is, of course, there is a 4 bond on the nitrogen, so that's why you will get a positive charge on this nitrogen. Okay, of course. Now what happened? This OH minus is acting as a base, right? So that's why this OH minus will take a proton from this oxygen hydrogen. Okay, and then you will get something like this, R N here, and this is R2 here, and this is our R3, and this is our O minus. Okay, and here is a positive charge, and this is called 3-degree amine oxide. This is called 3-degree amine oxide. So so basically, if you ask me why this nitrogen lone pair is attacking on this oxygen, okay, so I will give you a reason. See, basically, you all know that O single bond O, this is a very weak bond, very weak bond. Okay, very weak bond. So this is the driving force of the reaction. So that's why this nitrogen lone pair is attacking on this oxygen to break this bond, because oxygen, single bond oxygen, is a very weak bond, so it wants to break. But how it break? So that's why we are attacking the nitrogen lone pair on this oxygen to make them break, to to make them break this weak bond. Okay, O single bond O is a weak bond, so that's why it wants to be break. So that's why this nitrogen lone pair is attacking on this oxygen, and then this bond will be break, right? So this is the reason behind this reaction. Okay, I hope you will all understand. Sorry. Now what happened? See, after that we are giving a heat here, heat. Okay, so basically now you will let me show here is the alpha and beta position, so that you will clearly understood what I am trying to say. So this position is the alpha position and this position is the beta position. Okay, so now what happened, because I have already said that in here, in this reaction, in this elimination reaction, there is a Syn elimination will be happen. Syn elimination will be happen. It means I am telling you, see here, let's suppose here you have N, here we have here is a H, here is a O minus here, and you have here R2, here is a R1, right? And you have here is a R3, right? And here is a positive charge on the nitrogen. Okay, so what happened? So you all know that numbering here, this is the alpha position and this is our beta position. So because this O minus, right? Because this O minus is acting as a base. Why this is acting as a base? Because O on the oxygen there is a minus charge, right? So this is a electron density available here, right? So so that's why oxygen have a negative charge, so that's why it is acting as a base here, and this O minus will take a proton from this beta position, right, this hydrogen. And after that what happened, simultaneously this bond will get break and this bond will get break and goes on nitrogen as a negative charge, and now you will get something like this. R here is a double bond, and plus you will get something like this. Here is a nitrogen, here is a R2 here is a R3, and this is a R1. Okay, let me show R1 here, and here is a OH. Okay, so this is basically, this is our major product. This is our major product. Okay, so now you can ask me, we have here because we know that in this elimination reaction will be occur Syn elimination, so that's why we are taking this O minus, okay, and this hydrogen. Let me show you from red color. This is our O minus here, and this hydrogen should be on the same side. Okay, should be on the same side. Then you can say this is a Syn elimination. Okay, because this O minus is acting as a base, right? So the work of base is to take a proton. So how it will take a proton? So both O minus and this proton should be on the same side. That's what I am trying to say. In the co-elimination, there will be a Syn elimination. Okay. Sorry. So this is what I am trying to say, that O minus and this hydrogen should be on the same side, so that this O minus will abstract this beta proton, and then you will get a major product as a alkene by elimination reaction. Okay, and plus you will also get a here is minor product. Okay, so this is all about the co-elimination, right? I am taking another example to more clarification. That example is a very standard example. Okay, let me erase all this. Okay, if you have any doubt in this reaction, you can just drop a comment in the comment box. I will tell you. Okay, I hope there is no doubt in this reaction, because I have told you all the steps reaction. all the mechanism, each and every step I have discussed in very much detail. Okay. So now I am taking next example. Let me show you. Okay. Let me erase all this. So I am taking here such a reactant here, substrate. This is a sorry, this is our CH3, that is above the plane, and we have here some groups, bulky groups here, let's say butyl groups, and here we have nitrogen here, that is also above the plane, and we have CH3 and we have CH3, right, and here is a lone pair. Okay, and we are taking here H2O2, right. So basically what happened, you all know that this nitrogen lone pair will attack on this oxygen, and then this bond will be gonna break, and then you will get something like this. Here is a CH3, and here you have nitrogen here, CH3, here is a CH3, and here is a OH, right. And because this OH minus is living, so this OH minus is now acting as a base, and it will take a proton, this acidic proton of this hydrogen, right, and then this bond will gonna break, and then you will get something like this. Now you will get something like this. Okay, here is a N here. Oh, okay, wait, there should be a positive charge on this nitrogen, because nitrogen has a 4 bond, so that's why it should be a positive charge, right. And now you are getting CH3 here, and wait, let me show. This is our O minus here, and this is CH3, and here is a CH3, and here is a positive charge on this nitrogen. Okay, so and here is also a hydrogen. You can assume here one hydrogen is above the plane and one hydrogen is below the plane. Okay, so now what happened, you have a possibilities, and here is also a hydrogen that is below the plane, and I have already told you in the cope elimination, there are two important features. What is the future? First is should be Syn elimination. Syn elimination is the first condition. Syn elimination. Okay, this is the first criteria, and then also there is another feature in the cope elimination. We generally form Hoffman alkene, right? Hoffman alkene. It means less substituted alkene. Okay, so that's why here is you can see this O minus is, this whole bond is above the plane, right? And this hydrogen is gonna below the plane, but this hydrogen is same plane, is in the syn with this bond. So that's why this hydrogen and this whole group, are both have a syn conformation. Okay, those are both on the same side, means this hydrogen and this whole group is on the same side, because it is also above the plane and this hydrogen is also above the plane. So that's why we are gonna, what we will do, see, let me erase all this. So that's why what I will do, this O minus will take proton of this proton, because this bond and this hydrogen are on the syn conformation, both are on the same side, but this hydrogen and this bond are anti. Okay, these are the anti-conformation. This hydrogen and this bond is in the anti-conformation, right? So that's why this base will not take proton, okay, will not take proton of this proton, okay. So the correct is what? This is a correct method. This O minus will take a proton, this proton, okay. Now you will get happen, now you will see what happen. See here, when this base will take proton and this bond will gonna break and this bond gonna shift on the nitrogen, and now you will get a alkene here. Now you will get a alkene. Now you will get a alkene, something like this. Here is a CH3, that is above the plane, okay, and you will get here is a alkene here. You will get here alkene, okay, and this is our major product. This is our major product, okay. Okay, so if this let me tell you one more thing, okay. So basically there is a Syn elimination is happening here. Syn elimination is happening here, okay, and this is our major product, that is the Hoffman alkene. Hoffman alkene, right? This is our major product, okay. Let me tell you one more thing. If this base, if this O minus will take proton from this proton, then you will get a alkene on this position, okay, and then that product will be a minor product, okay. That product will be a minor product, okay. See, let me show you here. Wait. This product is a minor product, minor, okay. This is our major. Let me underline this so you can okay. So this is our major product and this is our minor product, okay, right. I hope you all understand what is happening in this reaction. So you have to very clear, crystal and clear, that two more important things in the co-elimination. One is a Syn elimination is happening here, and the second one is the product alkene that is formed will be generally formed as a less substituted alkene, that is a Hoffman alkene, okay. In some cases, I will tell you the cases. In some cases, if there is a conjugation in the molecule, okay, then you will make a more substituted alkene, okay, right. I hope you all understand this reaction, this co-elimination. I have told you every step, each and every step in very detail, every step mechanism. What is the reason behind this mechanism? Why not this? Why this only? I hope you all understand very clearly. And if you have understand, then please like, share and subscribe my chemistry portal channel, okay, because on this channel we talk only about the organic chemistry. That's all, okay. So please make sure you have like, share and subscribe this channel. So तब तक के लिए टाटा बाय बाय, सी यू सून इन द नेक्स्ट एपिसोड सीरीज ऑफ नेम रिएक्शन सीरीज. थैंक यू फॉर वॉचिंग माई वीडियो.